Alright, time for the solutions for the recursive equation dealing with arithmetic and geometric sequences. So what your job is on each of these is to write the next few terms. Okay, let me do something that doesn't erase. Write the next few terms, write your recursive function, and the d equals part is identifying the common difference. So on this one, I'm seeing that the pattern is subtracting 2 every time. So if you keep subtracting 2, you'll get negative 3, and you'll get negative 5, and you'll get negative 7. And if you are subtracting 2 every time, then your common difference is going to be negative 2, because subtracting 2 is the same thing as adding negative 2. And so with that information, we can actually use that to get our recursive function. The recursive function for all arithmetic sequences, which is this type, you're going to start with this a sub n equals a sub n minus 1, and then you add your common difference, which would be adding negative 2, which is the same thing as just subtracting 2. And so this says any term is the sequence is the previous one minus 2, and then you have to tell it where to start. Well, that's just going to be the first term of the sequence, which is 5 right there. So that's what's going on these, and really I can start with the beginning of my arithmetic sequence stuff right here on all of these. A sub n equals a sub n minus 1, if I could write small. And then a sub 1 equals something, and then a sub n equals a sub n minus 1, and a sub 1 equals a number. And once you get all that for these things, you just plug in the two numbers here and here on all of these. Anyway, so that's what I'm going to do. On this next one, I'm noticing a pattern of subtracting 5 every time. So we subtract 5, you're going to get negative 2. We subtract 5, we get negative 7. Hold on one second. No, yeah, it's subtracting 5. Man, just a little bit off on this. Yeah, so subtract 5, subtract 5, subtract 5. 3 minus 5 is giving me negative 2. If you subtract 5 again, you get negative 7. If you subtract 5 again, you get negative 12. And with that, knowing our pattern is subtracting 5 every time, that's going to give us a common difference of negative 5. And right here on my recursive function, each term is the previous one. Well, after that, you got to subtract 5 from the previous term. That's how you get the next one. And your starting term is right there. It's just going to be 18. So that's what the a sub 1 is. On the next one, it's looking like we're getting a pattern of adding 7 every time. So if you add 7 to that, you'll get 44. If you add 7 to that, you'll get 51. If you add 7 to that, you'll get 58. And that's going to give us a common difference of just 7. And every term in the sequence is equal to the previous one plus 7 for the recursive function part. And you got to tell it where to start, which is going to be the first number there of 16. On 4, we're getting this constant pattern here of subtracting 12. So if you subtract 12, you'll get 60. If you subtract 12 again, you'll get 48. Subtract 12 again, you'll get 36. And that's going to give us a common difference of negative 12. And for your recursive function, you can do every term is the previous one minus 12 and start at 108. And so those are our first recursive functions. Moving on to the next section here, we're getting this pattern right here of going deeper and deeper negative, and it's a pattern of subtracting 4. So if we go 4 deeper, we'll get negative 30. 4 deeper is going to give us negative 34. And this next one, I'm going to write it down below because I'm running out of space on the top of my iPad. Anyway, if you subtract 4, you're going to get negative 38. And if you're going to subtract 4 every time, your common difference is negative 4. And your recursive function, every term in the sequence is the previous one. Let me write that a little bit more legibly. The previous one minus 4, and start your sequence at negative 14. So there's my recursive function. And you can rewrite most of this for all of these other portions here. It always starts out the same. Every term is the previous one, and then you do something to it. And then you tell it where to start your function. Let's say a sub 1 equals a sub n equals a sub n minus 1. And then a sub 1 equals something. And then a sub n equals a sub n minus 1. And then a sub 1 equals that. Anyway, so that's how those are all going to start. The next pattern here keeps adding, it's looking like 15. So if you take 74 and you add 15, you'll be sitting at 89. If you add 15 to that, you're going to get 104. If you add 15 to that, you'll get 119. So yeah, just keep adding 15. So my common difference is 15. And if you want to get any term in the sequence, take the previous one and add 15. And tell it where to start, which is right there at 29. That's my recursive function. The next one is getting a pattern of adding 11. So my common difference is going to be 11. If you add 11 to 94, you'll get 105. Add 11, you'll get 116. Add 11, you'll get 127. So every term is the previous term plus 11. And we're going to start our sequence at 61. For my next sequence, I just keep, you gotta look at that, figure out what your pattern is going to be, and that pattern is adding 6 every time. So if you take 63 and you add 6, you'll get 69, add 6, you'll get 75, and then you add 6, you'll get 81. So my common difference is 6, and so my recursive function is going to be every term is the previous one plus 6, and you need to tell it where to start the pattern, which is at 45. And this next guy here has a distinct pattern of adding 8 every time. So if we add 8, we'll get 14. If you add 8, you'll get 22. If you add 8, you'll get 30. And so my common difference is 8, because that's what I'm adding every time. And my function is going to be every term is equal to the previous one plus 8. And you're going to tell it to start at negative 18. So those are all the recursive ones for the arithmetic side. And when you get to the geometric side, all of these ones is multiplying by a specific number each time, in this case timesing by 2, all the way down. So my common ratio is going to be 2, because you got to keep timesing by 2, you'll get 96. If you times by 2, you're going to get 192. And if you times that by 2, you're going to get the infamous 300 and, hold on, I've got to write things upside down real quick. 384. And so since you have that, then you can start writing your recursive function. Every term is equal to 2 times the previous one. So I'm going to put the 2 out front of my recursive function, and I'm going to tell us to start at the number 6. So start at 6, keep doubling, and you'll keep going on with your function. So that's what a lot of these are going to take this form. You'll put some number in front, and then you'll say where to start. And so let me fill those in real quick. Alright, so now my functions are ready to go on this one. So you just need to figure out the next patterns here. If you go from 180 to 90 to 45, that's a pattern of dividing by 2, which will give you a common ratio of 1/2. And if you take 45 and you cut that in 2, you're going to get, here, I'm just going to do it over 2, so 45 over 2, it doesn't go evenly. And if you divide that in 2, you're going to get 45 over 44, and if you divide that by 2 again, you're going to get 45 over 8. And so you're going to take this common ratio of 1/2, which is what you're timesing by, and put that in front there. This says every term is the previous one times 1/2, and then the ace of 1 tells you where to start, which is at 180. The next pattern here is just a pattern of timesing by 3 every time. So my common ratio is going to be 3, and if you take 189 and you times by 3, you're going to get 567, and if you keep timesing by 3, you'll get 1,701, and if you keep timesing by 3 again, you'll get 5,103. And since my common ratio is 3, I'm going to put the 3 right there in front of that one, and then my ace of 1 is my starting value, which is just 7. And we'll move on to the next one. We have a pattern here of dividing by 2 every time. So 10 divided by 2 gives me 5. And if you divide that by 2, you get 5 halves. If you divide that by 2, you get 5 fourths. And so my common ratio, well, to get that, just take any number, divide by the previous one. 10 divided by 20 is 1/2. And so that number goes in front of that part of my recursive function, because every number is equal to 1/2 of the previous one, and we're going to start all these numbers at 80. So ace of 1 is going to be 80. That brings us to our last three here. Let me fill in the function part real quick. Alright, so on 14 here, we do have a geometric sequence because the pattern here is multiplying by 4 every time, so our common ratio is going to be 4. But if you take 128 and you times by 4, you're going to get 512. And if you take that and you times by 4, you're going to get 2048 or 2048. If you take that and you times by 4, you're going to get 8,192. And since my common ratio is 4, I'm going to put 4 right in front of here. Every number is the previous one times 4, and then the a sub 1 part tells you where to start, which is at the number 2. And then on 15, we're getting a distinct pattern here of timesing by -7, so my common ratio is going to be -7, which will go in front of my function here. And my a sub 1, my starting value is going to be 1. Now we just have to get the rest of these terms here, 334, when you times that, well, -343, when you times that by 7, well, -7, you'll get positive 2,401. And if you times that by -7, you're going to get negative 16,807. And if you times that by -7, you're going to get positive 117,649. Oh, there's just some big numbers there. And finally, 16, we're getting this distinct pattern of dividing by -3, which is going to give me a common ratio of -1/3, which will go in front of my function here, because every number is equal to -1/3 times the previous one, and you tell this function to start at 81, which is right there. You know, I just have to get the next one. -3 divided by -3 is going to give me +1, and if you divide by -3 again, you're going to get -1/3. Or you can times by your common ratio. -1/3 times -1/3 is going to give me +1/9, and we're good to go.